Okay, everybody, this is Mr. Baylor. Let's try me doing a little bit of a math video for you today. Please give me your feedback. Please let me know how this works. I know you can't see my face, but I don't think that's going to be something you're going to complain about too much. You can hear my voice, which is probably bad enough. So, what we're going to do is I'm going to take notes on this paper you see on the screen. It'd probably be best if you took notes as well on a separate piece of paper while we're watching the video. You can probably just copy mine if you want. So we are doing Module 1, Lesson 1, and this is called Exponential Notation. And you've probably worked with exponents before. You've definitely seen them before, but we are going to be working with them a lot this year. And you might be asking, why do we need to worry about exponents? Well, it really makes life easier. Let me explain why. First, let's go all the way back to primary school, first, second, third grade, those kinds of things. First thing you probably learned how to do when you were in kindergarten was add. You did something like maybe 3 plus 3. And we know that's 6. But then math gets more complicated because if you get, let's say you have a super bad job where you make $3 a day. Make $3 Monday, $3 on Tuesday, that's $6. But you're not going to stop working. You get $3 on Wednesday, $3 on Thursday, $3 on Friday. Now this is a long math problem. There is a shorter way to write it, which 3 5 times is just 3 times 5. Notice how I use that dot for multiplication. Not an x. We don't use an x a whole lot anymore because x can be confused with algebra and variables. So we use the dot. We'll use the x sometimes, but you need to be familiar with both. So 3 plus 3 plus 3 plus 3 plus 3 can be shortened to 3 times 5. So mathematicians like things shorter ways to write. What happens if this is called, let me get a different color. This is called repeated addition. The fancy word for repeated addition, and I know you're going to say it's not super fancy, this is multiplication. Multiplication is repeated addition. They are the same thing. And you learned it back here. It is, you might have heard multiplication is adding faster, but it's repeated multiplication, repeated addition. When we have the same number added over and over, multiplication makes it faster to solve. We can also do the same thing with multiplication. There is such a thing. What happens when we get 3, not plus 3, times 3, times 3, times 3, times 3? This is repeated multiplication. Repeated addition, repeated multiplication. Because it is multiplying over and over. Now, it's very important that it has to be the same thing being multiplied. The same value is multiplied repeatedly. This only works if we have the same number. So to write this problem shorter, we change it to 3 to the 5th power. This is called 3 to the 5th power. Pay attention, because where you label these things is important. This is repeated multiplication, also called exponents. Now let's talk about some common mistakes that we see middle schoolers make with this. When we write, let's say we write 2 to the 3rd power. When we ask middle schoolers what this equals, a lot of middle schoolers will say this equals 6. because they see 2 and they see 3. They think it's 2 times 3 makes 6. No. No. This is not 2 times 3. It's an exponent. It is 2 to the third power. 2 repeated. So what this really is, we get 2 to the third. This 2 is called the base. This 3 is called the power, or the exponent. To write this and solve it, we have 2 to the third power equals 2 3 times. Pay attention. It's not 2 times 3. It's 2 3 times. There's a difference. It's 2 times 2 times 2. Not 2 times 3. 2 3 times. Two 3 times. And to solve this, we do 2 times 2, which is 4, times 2 is 8. So 2 to the third power is 8. That is your introduction, quick introduction to exponents. Now, it is much easier, much faster to write 2 to the third power instead of 2 times 2 times 2. This gets especially true when the values get even longer. You might be saying, it's not that much faster, Mr. Baylor. I don't want to write exponents. Let me just write the multiplication. Well, what happens if you have something like 5 times 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 5? Takes a long time to write that. Why are you going to write like that? It is much simpler, much faster just to say, well, this is 5, because 5 is the base. That's the number that gets multiplied. And there are 8 of them. So this is 5, 8 times. So 5 is the base, because that's the number being multiplied. And the number of times is the power. 5 to the power of 8. Now this works for any number. So the rule this even works for fractions or decimals and negatives. As a fraction example, if we have 9/7 to the fourth power, we can write this as 9/7 times 9/7 times 9/7 times 9/7. This is 9/7 4 times. It also works with negatives. Although there is a small trick to negatives that you need to be familiar with. So let's pretend we have -2 to the fourth power. If you'll notice, I put the -2 in parentheses. The reason the -2 is in parentheses is because you have to tell people that everything inside the parentheses goes to the fourth power. Let me show you the difference between -2 to the fourth power with parentheses and -2 to the fourth power with no parentheses. This one is going to be -2 times -2 times -2 times -2. This one will be negative, because it's not in parentheses, 2 times 2 times 2 times 2. Both of them happen 4 times because the base, but if you look at this, the negative is here. Now you might be saying, who cares? Well, the answer cares. Because if we do -2 times -2, the negatives cancel, so that's 4. -2 times -2, that's 4. So 4 times 4 is 16. But this one, 2 times 2 times 2 times 2 is also 16, except the negative never was brought in. So the negative stays separated, so the answer is negative 16. So just those parentheses are a big deal. So this works for any number, works for positives, works for negatives, works for fractions, works for decimals. So because it can work for any number, we have to make a rule. So just like you learned when you started doing algebra, any number. So if we have any number, let's just say x. So it works for any number, x as a variable. And because it can work for any power, we have any number of power. So instead of numbers, we're using variables, x to the n. So what happens when we do x to the n? We get x times x, no idea how many times, but we just keep multiplying x. That's what the dots in the middle mean. It means it keeps going times x. How many times? Well, n times. So we have x's multiplied by each other, because those are the bases, by however many times we see here. So that is what we're working on a little bit. So let us do some examples together. For this, you're going to need your workbook starting on page 1. So this is your workbook, page 1. You'll see exercise 1 all the way to exercise 10 on this page. We're going to do a few of them together. And so follow along. Now look at exercise 1. The number being multiplied is 4. So the number multiplied is our base. How many times it's multiplied is the exponent, is the power. So this is 4 to the 7th. Because 4 is being multiplied 7 times. Now exercise 2 is asking you to work backwards. We see the answer is 3 6/10 to the 47th power. Super long to write out. Thank goodness for exponents, so we can write it shorter. So we see the 3.6 is multiplied over and over and over again. How many times? We'll look at the exponent. 47 times. Exercise 3. Oh, a negative. Okay, we can do this. The number being multiplied is negative 11 63/100. Make sure you keep the parentheses. That is your base. Remember the parentheses. It makes a difference. How many times? Well, we look down here at our brackets. To the 34th power. And exercise 4. We have 12 multiplied by itself over and over again. We have the exponent 12 to the 15th power. So 12 is the base because that's being multiplied. How many times do we multiply 12? 15 times, just like that. Take a minute, work on exercises 5, 6, 7, and 8. Pause the video so that you can work on it on your own, and then I will have the answers for when you unpause the video. Okay, welcome back. You should have paused the video. Here we go. Exercise 5, you should have got negative 5 as the base. That's being multiplied to the power of 10. Exercise 6 on the other side. We have the fraction 7/2. That's our base. And the exponent is 21 because it's 21 times. Exercise 7 is negative 13 to the 6th power. Exercise 8, a negative fraction, negative 1/14 to the 10th power. Now I asked you to stop at number 8 because I wanted to talk about number 9 and 10 a little bit, because this makes sense, but I want to show it to you anyway. We said this works for any number. So we follow the same pattern. In exercise 9, it's x's being multiplied. So x is the base. We don't have a number, but we don't need a number. We have a variable instead. A variable is just as good. How many times? 185 times. That's exactly, the only difference is we're using a variable instead of a number. Do not let the variable scare you. And do not let the variable scare you with number 10. We have x is the base. How many times? N times. That's it. That's good. We got it. Let's go to page 2. Turn the page with me. This is your page 2, exercise 11. We're thinking a little bit now. So this is going to take some explanation. So if you need to take a break, pause the video, because this is the next logical step. It will make sense, but if you need a brain break, pause the video. And then we're going to keep going right now. Now it's asking, will these products be positive or negative? How do you know? Well, let's work it out. This one is -1 multiplied by itself 12 times. -1 to the 12th power. Let's just do the math and stretch it out. So we need -1 to the 12th power. So we have -1 times -1 times -1 times -1 times -1. I hope I don't run out of room. Times -1, that's 6, 7, 8, 9, 10, 11, and I'm going to add 1 to the beginning because I did not plan ahead well, but that's 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, that's 12 times. This should show you why exponents are such a great deal, because instead of writing this whole thing out, we can just write something else short. Anyway, so let's break this down and do pieces at a time. I know -1 times -1. These two together make 1, because a negative times a negative makes a positive. So these two together will make 1. These two will make a 1, because negative times a negative, positive. -1 times -1 is positive. -1 times -1 is positive 1. So all the negatives went away. So now we can just do 1 times 1 times 1 times 1 times 1 times 1. And I don't know if that was 6. But you get the answer is going to be a positive 1. So this one is going to be positive. So why do they think it might be negative? Well, look at this one that is almost exactly the same, except for this time -1 is raised to the 13th power. Here I go again. This time I'm going to spread out a little bit, give myself a little bit more room. -1 times 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 negative. I need to count. I don't know how many I've done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Double check again just to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good. Okay, let's start combining them. We know a negative times a negative makes a positive 1. So we know -1 times -1 is 1. 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 Uh-oh, this one sad, does not have a partner. So that one, no partner, stays -1. Now we have to multiply all of those together. So we do 1 times 1 times 1 times 1 times 1 times 1. Uh-oh, there's one extra -1 that did not get paired up. When we paired them up, all of these turn into 1s. This one did not have a partner. So this one changes all of these to be -1. So this answer is negative. So that's part of the question. Will these products be positive or negative? -1 to the 12th power is positive. -1 to the 13th power is negative. How do you know? Now, I'll be honest, this is the question that a lot of middle schoolers skip. How do you know? Well, how did we know these answers? We stretched it out and did the work. So how do we know? We stretched out the problem and did the work. That's it. That's how do you know? We did the work. But some of you have probably noticed what the rule where you don't have to stretch it out to do the work. Because if you notice, this one, when every one -1 had a partner, turned into positive. In this one, when somebody was left out, it was negative. Now, what is the difference between this one, when everybody had a partner, and this one, when there was somebody left out? What do you think? Take a minute, look at both of those, and tell me what the difference is. Hopefully, you said the difference is that 12 is even, so that we have even groups. 13 is odd, so there's an odd one out. There's an odd person out. This person does not get a partner. It's an odd number. So even and odd. And that is the rule. If the exponent is even, the answer will be positive. If the exponent is odd, it will be negative because somebody is left out. This works, this is true, when there is a negative base. So let's look at exercise 12 together. Let the directions say, is it necessary to do all the calculations to determine the sign of the product? Why or why not? Now here's the thing. Is it necessary? Do you have to do all the calculations? Do you have to stretch this out to determine, to find the sign of the product? Product is the answer to a multiplication problem. The sign is positive or negative. So do you have to do you have to do all the work to tell me if the answer is positive or negative? The answer is no, you don't, because remember, -5 to the 95th power. 95 is an odd number, which means the base is negative, so 94 -5s are going to have buddies. But the 95th one is odd, and so it's going to be an odd number because there will be somebody left out. So you say, no, I do not have to do all the work. No, because 95 is odd, and there will be one -95 without a partner. Now that's how I worded it. You can word it a different way. Looking at the second part, we have a negative base. Is this product, is the answer with the negative base going to be positive or negative? Well, again, look at the exponent. 122 is an even number. So we know because it's even, every -1.8 we write down. If we write down all 122, and I'm going to need a few more pieces of paper, we write down all of those, they are all going to be paired up. So do you have to do the work? No. 122 is even, so all negatives will have a negative partner to cancel out. We'll have a negative partner to create only positives. I hope that explanation makes sense to you. It's a little trick. You just look for odds or evens. If it does not make sense to you, please talk to me. Schedule an appointment. We'll do a Google Meet. We'll talk more about them. Let's look at page 3. I want you to do a little bit of page 3 on your own. Exercise 13, fill in the blanks indicating whether the number is positive or negative. Solve it. Pause the video to solve it, and then come back. We'll show the answers. Okay, so exercise 13, hopefully you paused it, solved it. If n is a positive even number, then negative 55 to the n, so n is positive even. Even means that every negative 55 will have a partner, so the answer will be positive because everyone has a partner, all the negatives cancel. What about if in negative 72 and 4/10, if n is a positive odd number? Odd means there's a leftover negative 72 and 4/10 without a partner, so that leftover one changes everything to a negative. If everybody has a dancing partner, the whole trip is positive. If one person is odd and left out without a dancing partner, the whole dance is negative. You can think of it that way if you want. Now, I'll let you work on this yourself. Josie says that negative 15 to the 6th power equals negative 15 6 times. Is she correct? How do you know? Try it out, answer it. You can check the answer pages through the link on the daily schedule to see if you are correct. There is also on page 5 the exit ticket for a little bit more practice. The answers for that are also linked on the daily schedule. You can check your answers to those. Make sure you try them. This number 1 is writing and asking positive or negative. Number 2 is filling in the blank for how many times. And number 3, Arnie, is he correct? And here's a hint for number 3, check his parentheses. Check his parentheses. And then for more practice, don't forget you also have the homework helper on page 7. Homework helper is kind of a summary of everything we've talked about. So the homework helper is a little bit of a quick review for you to look at yourself with some thought bubbles that explain the thinking. And then extra practice, the problem set on page 9. So that's your problem set. The answers to the problem set are also on the link in the daily schedule, so you can check your answers to all of these. Do your best, take your notes, use your notes, think about what you're doing. You can talk to your friends for help. And don't forget, I'm also available. Send me an email, send me a message, and I can help you individually. Good luck on this. I hope this video helps. Remember to think about the video. Tell me at the end of the day if this video helped or if we need to make some changes. Have fun.